multiplying monomials. So the product of powers property, product means multiplication. Okay, so that's where I have, say, a to the m times a to the n. What happens is that if you have the same base or like terms, you add the exponents. So if I have x squared times x cubed, when I add those together, I get x to the fifth. If I have y times y to the third, you have to remember, if you don't see an exponent, there's a 1 there. So this is going to give me y to the fourth power. Okay, so again, when you have this, sometimes the multiplication might be represented with a parentheses, and that can get confusing because we see parentheses a lot when we're talking about raising to a power. So ask yourself, is anything being raised to a power besides the individual terms? No, this is multiplication. So I get z to the fifth here. If I move too fast, you can slow down by rewinding or pressing pause. Okay, let's do power of a power property. So this happens when I raise a power, so a monomial to a power. So here this is not multiplication. This is not two terms being multiplied like in that previous case. This is a to the m being raised n number of times. What you do is, since exponents represent repeated multiplication, you end up multiplying those exponents. So for example, x cubed, if I raise that to the second power, that's going to give me 6. 3 times 2 is 6. The reason being is that x cubed is being multiplied by itself twice. That's x cubed times x cubed. 3 plus 3 is 6. That's how you can check your work. Another thing you might see is where you have, say, a exponent on the outside, and you have a coefficient. This coefficient, that 4, you also have to raise that to the second power. Okay, that's 4 squared. That's going to give you 16. This y squared, that 2 times 2, that gives you y to the fourth. So don't forget that. The power of a product property, that's where you have multiple things. So that's actually kind of like this case here. So if I have AB and I raise that entire thing to the m power, well, remember that each of these is being raised to the first power, even if you don't see it. So 1 times m is am, 1 times m. So it might be easier to see if we have some numbers there. So let's do an example where I have a squared and b to the fifth. Let's say I raise this entire thing to the third power. Again, take a moment to think. I'm not multiplying this term by another term. I'm raising it to the third power. So 2 times 3 is 6. 5 times 3 is 15. Sometimes you'll have multiple terms. Let's do one where you have a negative. Let's make this a -2 there. Okay. So here, you notice this is a -5 and I'm raising to a negative power. First, you want to raise everything to just multiply those exponents. So this is -5 being raised to the negative first power. This -2 times -1 would give me a +2. And this +3 times a -1 would give me a -3. The next step I would do is move any term that's being raised to a negative power to my denominator. So these are all separated by multiplication. I have x squared in my numerator. That -5 to the first, I put in the denominator, so it's gone. This y to the -3 power, I'm going to put that in the denominator, so now that's a positive exponent, and now we're done. You might notice that if you raise something to the first power, you don't necessarily have to write the exponent. My final answer here, well, if I look at the top here, it's positive being divided by negative, so that makes the entire fraction. I'll write it this way. I'd accept it if it was written here, but I just want you to understand why this is. You have a positive value, think there's a 1 up here, 1 divided by a -5 gives you a -1/5. I don't have to write that 1 out front.